Good morning, everybody. Welcome to another Wednesday webinar, proudly sponsored by the Dairy Standard Agency. It's good to see you all. I'm Jacqueline Oudendal from the DSA, and Jandri Klopper from Plaas Media will facilitate the question and answer session at the end of the presentation. Special thanks to Plaas Media for their marketing and technical support. We have an interesting topic today, which is hygienic design, critical principles underpinning safe, efficient operations. And we are fortunate to have an expert, Piet Grobler, once again with us to share his knowledge on this subject. You are welcome to write your questions in the question bar, or you can raise your hand during the Q&A session to ask your question directly to the presenter. And then Jandri will allow you to speak, but then you just have to unmute yourself. It gives me an absolute great pleasure to introduce Piet Grobler. He is the chair of the European Hygienic Engineering and Design Group, and he is an authorized trainer and the head of hygiene and food at the OFT group. Over to you, Piet. We are looking forward to your presentation.
Jacqueline, thank you very much. Can you hear me clearly?
Yes, we can hear you clearly.
Thank you so much. Thank you, Jandre, as well. Ladies and gentlemen, thank you very much for this opportunity. Thank you for dialing in today. I hope that the topic and the journey that we will be taking around the whole concept of what is safe, efficient operations, and bearing in mind when we talk about safe, it's not just food safety specifically, but also the safety of equipment. How do we prevent any damage to our equipment, etc., and what is the impact? So we will be taking you on, I will be taking you on a journey. Of course, obviously, all of these principles would have started and would have originated somewhere. We would go through a couple of concepts that I like to refer to as efficiency and efficacy when it actually comes to food processing and to cleaning and disinfection specifically. And we will also look at some aspects of hygienic design risk management. How do we approach it? And I will also share with you some examples of work that we've done in South Africa. And they'll also give you some feedback from companies globally that the positive impact they've seen through a very clear and dedicated focus on design, and specifically hygienic design. So that is the topic or the content of what we will be covering this morning. I think just by introduction, Jacqueline has done that. So my name is Piet Grobler. I've been in the food and beverage industry for the past 40 odd years, providing all types of solutions to the industry on the hygiene side, microbiological side, food safety, etc. But the topic for discussion today is what are those principles that's important when we look at hygienic design. So where did all of this start? So I will give you a basic introduction on the European Hygienic Engineering Design Group, the association that we represent in South Africa. We as the OFT group, and share with you the key activities on how they would approach the whole concept of hygienic design. And as I said, we will then look at aspects of efficiency, efficacies, and risk management for that matter. So is EH? EH is an acronym for European Hygienic Engineering and Design Group. It was founded in 1989 as a non-profit consortium So you can just imagine and think to yourself is that the food industry would have sat and looked at all their methodologies and all their activities pertaining to managing food safety within their facilities. And one aspect that came to mind is that equipment that is being supplied to these food processors, how best to manage that from a food safety perspective, and how do we ensure that it is properly cleanable, we do not have cross-contamination, and how do we ensure that our processes are producing food that is safe for the consumer. So that is in essence where we at. The different stakeholders was obviously the food producers, also companies providing services, be it equipment, hygiene, and other services to the food industry, involving research and institutes. Specifically, when you think of Europe, there's a lot of regulations, etc. So there's a whole host of regulatory aspects that need to be covered. So involving public health authorities also made a lot of sense in terms of collaboration to form a platform where hygienic design can be discussed, concepts can be discussed, issues, shortcomings, because that's important, is where are our shortcomings, and you will see that EH addresses those aspects very, very clearly and very specifically. They look at some of the member companies, so it's based on a membership. The association is based on a membership, so you'll see a number of international companies, either suppliers or food processors, that forms part of this association, and a number of them obviously operate within South Africa. And as regional section South Africa, we are endeavoring to get all these suppliers involved as well, and these manufacturers involved in local collaboration and in addressing issues that is of concern when it comes to hygienic design or then food safety for that matter. So as an organization, it's a worldwide. I'll share with you the spread within the global spread, but it's covering all the globe in totality, and it's addressing a number of aspects, as I said, pertaining to food safety, to hygienic design, and it's really there to support industry, specifically in addressing these issues in a cost-effective and sustainable manner. And those are the two aspects that we will, from a principle perspective, hygienic design principle perspective, will be unpacking this morning. As I said, the structure is a voluntary contribution of members. So we have members, we have working groups that actually put together guidelines, and from there we would then have a training material for industry and others, and I'll get to those aspects as well. It's also collaborating very closely with auditing companies, food safety auditing companies like the Foundation, the FSSC Foundation, IFS, and others. So there is collaboration across, we talk about from farm to fork, and so it's a collaboration across all sectors and all steps within our supply chains to ensure that matters are taken into account that needs to be taken into account. And around food safety is, we all know about that food safety is not a reactive approach. It is being proactive and addressing whatever could go wrong before it actually happens. So a very structured approach. The objectives is really to guide the industry, and very importantly is to identify areas where hygienic design is insufficient. So what happens is that EH would write guidelines, specific guidelines on specific matters pertaining to equipment, for example, or processes, and based on the requirement, would then put together working groups involving subject matter experts globally that would form working groups, and the outcome would be a guideline or a series of guidelines to assist industry. So again, from a South African perspective, is we have enough tools through this process to support the local stakeholders and also industry in totality. As I said, EH writes guidelines. There's over 60 guidelines currently. Very important is, and we'll go through the one or two of them. Very important, they're guidelines. So in other words, they aren't standards specifically, but guidelines that you as producers or you as service providers to the industry can make use of, because it's quite comprehensive and quite detailed. What EH also does is on specific equipment, is they would test equipment for cleanability. It is a physical test done in laboratories, accredited laboratories, and based on the outcome of those tests, if it conforms to the requirements, EH would then issue a certificate on items relating to pumps, valves, and different components that would be used typically within the food processing process. There's 300 plus active certificates. All of the information is available on the EH website. So if you require any information, please have a look at that. We talk about brand protection, help to prevent reputational damage. Obviously, a recall of any nature costs a lot of money. It's not necessary if we apply the knowledge that we have, and bearing in mind, again, as I said, the knowledge is global knowledge on very specific subject matters, and as such, we can apply our minds, use the tools, and prevent any damage to our product, to our processes, etc. And it's all about food safety, producing safer food, cost efficiency, we'll talk about that, and then sustainability, which is obviously as important as all the other aspects, gets also addressed through proper approach to hygienic design. That's just some uniqueness. It's a comprehensive guidelines. I've already spoken about the guidelines. There are some guidelines on the EH website that can be downloaded free of charge. Members have access to all guidelines, and then the other guidelines can be purchased from the website. So there's a comprehensive range of guidelines. We talk about a collaborative approach. Again, collaboration is important with all stakeholders, and from that collaboration is where ideas would be generated, and that would go then through the different steps within terms of working groups, etc. A worldwide presence, as I said, it is represented across the globe. On the training aspect, so from the working groups, there's guidelines. From the guidelines, training material is then generated. Trainers are then certified. We have 2 certified trainers within South Africa, of which I'm one, a EH certified trainer. So from the guidelines, there's training material that gets developed by a subcommittee looking specifically at training and education. And then addressing hygienic design challenges. So where there are any shortcomings that gets identified, that is where EH would focus strongly, and then get subject matters to support the industry. And obviously, it's a holistic approach. Already spoken about the guidelines. As I said, some of them are free of charge to be downloaded. So it's based on membership, and from the membership, you can also again look at the detail on the website and see what are all the benefits should you wish to become a member and contribute to the efforts of EH globally. Members can become part of working groups and support the industry in that manner. There's just some examples of a guideline. On the training, EH would issue certificates based on the type of training. We have advanced training, and we have other trainings that EH does. And this is a typical example of a certificate of compliance of piece of equipment that was tested in an EH certified laboratory. And just as a matter of interest, these certificates has to be renewed every 5 years. So again, what does it give you from an industry perspective? It gives you the opportunity to collaborate with your suppliers and with your service providers, and see if they can support you in this manner. So when we look at the hygienic design, there's just some focus areas of working group, but in general, what is important when it comes to hygienic design? There are basic principles, and we're going to touch on a couple of them a bit later. But what are the principles? We have the saying is that, for example, on the design of a piece of equipment, there's an area we can't see, we can't reach it, we can't clean it. So again, that's a very broad statement, but it's a principle that we need to apply. So accessibility is important. We will look at aspects like drainability. So a number of principles. The materials of construction is, and that involves anything from stainless steel, type of stainless steel we use, other metals we use, elastomers, plastics, etc. So all of those things need to be taken into account when it comes to hygienic design, to ensure that it is properly and it does not cause harm to our product, and obviously prevent harm to the consumer. Now, the what's name is holistic in the sense, the approach is holistic in the sense that hygienic design relates to the equipment, the pumps, the valves, etc. But it also relates to the factory design. If we were to start a new factory, should our approach be? What is important? What are the aspects we need to look at? If we do an extension to a current facility, what is important? What do we need to look at? So all of that gets covered. Closed equipment, we talk about, we differentiate between two types of equipment. We talk about closed equipment. Again, you can think of in your industry, on the dairy side, closed equipment mainly, unless when you come to cheese, there's some open cheese manufacturing, there's open equipment. So again, your risk differs depending on your process, and those things gets addressed through the guidelines. Cleaning and validation very importantly, I'll share with you some practical aspects a bit later in the presentation. So again, you can see there's a whole host of topics that gets addressed. How do we integrate our processes, our equipment? And we see that a lot in South Africa, where equipment is, where factories are producing and their production increased. So a new line is to be brought in. How do we integrate that into our system to ensure that all risk pertaining to hygienic design is mitigated? So all these principles we need to look at. The factory itself, as I said, the packaging machinery, cleaning and validation, what is important. We do a lot in the dairy industry, a lot of CIP cleaning. What is important when it comes to CIP that we need to consider? There's specific test methods that is being used. As I said, the test method is a physical testing of the equipment, and it's done in a laboratory. So very specific methodology and evaluation, and based on that, based on the outcome of that, a piece of equipment will either be approved or certified or not. And again, there's a whole process that's involved. When we talk about closed equipment, as I said, there's a difference between closed equipment from a risk perspective and open equipment. Closed equipment, you can think of mechanical seals, other seals, sensors, devices, etc. That needs to be considered, not just from an aspect of is it cleanable, but also from an installation, maintenance, all those aspects that need to be considered. That's a nice overview of how the guidelines fit into a process. So from handling and storage of raw materials, we started at this point. There's the different guidelines that speaks to aspects relating to raw material handling. We talk about processing. You can see the number of guidelines that is relevant to the processing step itself. Valves, sensors, seals. Again, the list of guidelines applicable. Because again, if those things are not hygienically designed, if it's not installed correctly, your risk of contamination or by either soil, or chemical or residues, microorganisms, then obviously increases. So again, we need to look at all of those aspects. Pumps, pipes specifically. There's the list of the number of guidelines speaks around aspects relating to piping. One aspect that we do a lot of work in the dairy industry, and pipe couplings is an issue. Again, EH has a white paper. They've written a white paper that can be downloaded free from the website that gives you a bit more insight in terms of pipe couplings and selection of piping or couplings when you do extensions, or when you do modifications, or when you wish to replace existing couplings. Welding, very important aspect. There's some excellent guidelines giving specific guidance around the importance, what is important during the welding process. And again, the importance thereof is if that process fails us, then obviously can have areas where we have rough surfaces, etc., that can actually give us hygiene problems or micro problems in our process. So welding, very, very important. As I said, we have a global reach. You can see there. In South Africa, we launched in 2019 the regional section South Africa. So we've been quite active and with a number of sectors, and both from food processors and also equipment suppliers in South Africa, around education, around auditing, around physical assessment of facilities. Here it's also some webinars that you can sign up to. Again, it's all about training. We spoke earlier about it, is that this is all about knowledge transfer. So we have subject matter experts that give us the guidance, and it's for us to transfer that sort of level of education and level of understanding to the market and to the industry in totality. There's some publications and newsletters, etc., that can give you some good guidance. We have the World Congress in this year in Vienna. Again, you can read on the website regarding that. Just want to spend some time on our activities in South Africa. We'll be exhibiting at ProPack and at the Food Safety Summit this year. We have our director from the Netherlands, Adwee van der Berg, that will be presenting at this Food Safety Summit. So again, on the topic of hygienic design, we're doing a presentation at the SASDT. We have a close collaboration with the DSA as it's currently. Also work closely with the University of Stellenbosch and University of Pretoria. Very exciting from the University of Pretoria is that we have now included hygienic design modules into the food science students program in third year. So we've included some of these modules into their degree. So from last year, everyone going through that program will obviously have an understanding of hygienic design. And then we're running a summer school also in Vienna, where we're going to collaborate between University of Pretoria, University of Bochum in Vienna, and another university, 3 universities, where we're taking students to do a summer course starting from a design of a facility, practical design of a facility, right through to making the end product. So that'll be the first, it's a pilot and the first of its nature. And then we have a 3-day advanced training course. Next one in Pretoria is 22 to 24 June. And we also have one planned for 9 to 11 in Cape Town. Very hands-on, 3 days. We look at equipment. We get subject matter experts on specific matters to come and talk to us about hygienic design. There's an exam at the end. And if you then qualify, you'll get certificates from the University of Pretoria because it's accredited by them, and then also from European Hygienic Design Group head office in the Netherlands. All right, so that is it. That's it. So that's where I said I'll take you on the journey. That's where all this information starts. We have access to that information. So how does this affect us when we talk about operations within South Africa? So we talk about efficiency and we talk about efficacy, but there's a trade-off when we look at applications. In other words, when we look at and we take the cleaning part of it specifically, you have a couple of parameters. You've got temperature, you've got concentration, you've got time, you've got flow. So what impact does it have on efficacy? So I'll just go through one or two of them, but for example, temperature, especially when you have high fat content, the higher the temperature, the better you're going to improve on efficacy. But from an efficient, in other words, from a cost perspective, it's going to increase because you have to you have to you have to put in more energy. So obviously that comes at a cost. Interesting is that the chemical concentration, that is our expertise, is around chemistry and chemical solutions, is that there's an optimum when it comes to chemical concentration. So typically you would think that increasing a chemical concentration is going to give you a better result, but there are instances and processes where, as a matter of fact, increasing chemical concentration is actually going to have the reverse effect. Okay, and then obviously the impact from efficiency is the wastage that's being reduced. Obviously, if it's optimized, you're not wasting money, water, energy. We talk about all those things as from a sustainability perspective. Flow, especially when we talk about CIP applications, what is critical for soil removal, we need that mechanical action. So from efficacy, we need the flow. There are, again, specific guidelines. What is the correct flow? How do we measure it? These are all aspects that we do during our CIP assessments in plants, is looking at, for example, flow rates, etc. And I'll share with you one or two things on that topic later on in the presentation. Right, so efficacy is we want to clean a piece of equipment, so we want to do it effectively. What are the aspects that we need to consider to ensure that the outcome is what we desire, and that the outcome is based on our validation? EH has a guideline specifically on validation and verification, which is very important from a cleaning perspective. So what are those aspects we need to look at? Obviously, we need to look at our soiling. What type of soiling do we have? Is there any heat involved? So all those aspects we need to consider. The cleaning process itself, we talk about time, temperature, etc. That is important. Those are criteria that's important from a cleaning process to give me the effective cleaning. And then on the equipment and facility design, that's very important, because again, we need to look at the construction material. Doesn't help we remove soiling from material, but we corrode the material, for example. Our surface finish is very important. So what is our surface finish? We talk about the design criteria, and I've already touched on that. As I said, aspects like, is it accessible? Is it cleanable? Can I reach it? Can I clean it? Those aspects becomes important from a design aspect, and bearing in mind it's equipment and facility design. So it's not just doesn't just relate to the equipment. So when we talk about efficiency and sustainability, maintaining validated efficacy. So remember, we validated our processes in order to get an effective, clean result. That is what we need to do. So what about efficiency? So if you, again, from a hygienic design perspective, and we'll talk a bit later around that, is that if you can, during this design phase, build in a specific number of hurdles that you can put in place, that is going to give you an opportunity to actually benefit on aspects relating to sustainability, then obviously it's a proactive outcome, and it's not reactive as we would normally do at a later stage. So the design phase is very important. So what are those aspects of water consumption? Okay, how much water are we using? And I'll share with you some data from global companies in terms of what they've managed to achieve from a sustainability perspective when it comes to water usage. You can just think if we do not have, and we can take CRP as an example, is inadequate flow, not going to get a good result, will result in more cleanings, etc. We need to use water, we need to use chemicals, all those things will then have a negative impact. Whereas if it's optimized, then obviously we'll get the benefits around that. Maintenance, waste, these are all benefits from a sustainability perspective. On the validation process, and this is a very good diagram, and it's also from one of the guidelines, is how do we approach it? So when we talk about cleaning validation, is the most important step within this process is actually the user requirement, and we call it URS, and the idea phase, and then the functional specification, where we can actually specify, or the supplier could specify how it needs to be cleaned, what is the best operation, what are the best parameters, etc. If you do it during the design phase, what is important then is when you go up to the V on this side, is it's going to make the validation so much easier because it's already, aspects are already addressed during the design phase. So very importantly that we get to that aspect. We see in South Africa more and more discussions between, for example, retailers and their suppliers, and from their suppliers to the equipment suppliers, that collaboration and communication in terms of aspects relating to this, what we call the V model. Right? So what are the outcomes? Is just two pictures of, if it's not properly validated, it's just a pipe with soiling still in the pipeline. So obviously there's something wrong with the process, and plate heat exchanger just soiling. Again, when we look at risk mitigation, is we have a number of tools to actually use to mitigate those risks, albeit from a design perspective, albeit from a process perspective, or even from a chemistry perspective that we can use to address the shortcomings. So just some documented benefits, and again, this is not South African data, this is global data, where people through proper hygienic design, water usage saving 20 to 40% reduction in CRP water use, again because the CRP process is optimized. Energy is if we can clean whatever temperature it might be, if it's validated properly, we don't need to adjust temperatures and aspects like energy that will impact the cleaning result, for example. So there's saving on energy. The chemicals, again, more coverage, etc. We need to consider that specifically as it relates to, for example, foaming equipment, labor, maintenance. Again, we do a lot of training with maintenance teams across South Africa. And again, once you start looking at these aspects and methodologies to follow, you can actually see how much through proper maintenance programs, how equipment's lifespan can be increased, and other parts and components can be increased. So a lot of benefits there. And then waste handling. There's some cost savings and ROIs, Nestle 30% reduction in CIP water use. Okay, just because of a more efficient cleaning. Again, CIP cleaning very important. GA 2.5 2 to 5% increase in yields. Okay, so, and just by reclaiming the product adequately. And again, it comes to hygienic design. Is my equipment designed to be, for example, fully drainable? If that is the case, I can reclaim more product or a greater yield of my product as if it's not designed properly. Again, so there's a whole host of examples of cost savings when it comes to applying the concept of hygienic design from start and not as an afterthought or later on in the process. Right. So the risk management, it's an integrated approach. EHF written a guideline 58, and in the guideline speaks to both the manufacturer of equipment and also the user of the equipment. So again, that collaboration between the user and the manufacturer and the design team becomes critically important. So again, close collaboration, and the guideline speaks to both these parties, and obviously the collaboration between them. So when we look at hygienic design objectives, why is it important that our equipment is hygienically designed? We talk about three aspects. We talk about prevention of ingress. So in other words, any contaminants that can enter the process. So again, we want to eliminate that. Prevention of growth. So if you have soiling microorganisms, obviously soiling is the source of food for microorganisms. You start getting micro growth. So we want to prevent that, and we want to prevent accumulation of soil, dirt, cleaning chemicals, etc. So these are really the objectives relating to the guideline, what we need to prevent from a hygienic perspective. Hygienic design. What are the principles? There are 10 principles, but in this guideline, we're looking at 5 principles. We talk about the ability to drain. Why is that important? If we have any equipment or surfaces that's not drainable, obviously that's water, source of contamination. Ability to clean. Can we clean it? Can we clean it effectively? The material of construction, we already discussed that, is we do not want to damage that surfaces. Ability to segregate, and then ability to access. So it speaks to these 5 principles. And the approach is about understanding the scope. And it's very similar to, and we're all aware about the food safety management system process. So we look at the scope, the context, and the criteria. We look at a multidisciplinary team, really just to get everyone involved, bring their expertise. So it's a multidisciplinary team, and a hygienic design assessment will be conducted. And again, the outcome is so that we can be proactive in ensuring that we've addressed all the shortcomings that we've identified. And we'll talk now about life cycle, about equipment and facilities for that matter, is that where are we in terms of life cycle, and what do we need to do to mitigate any risks? So I spoke about the life cycle. So they've identified 6 life cycles, but the important one is the design phase. So the more you can do during the design phase, identify issues, and that they do through technical drawings and a whole host of resources that they would use to during the design phase. And then it can also be managed late in the life cycle. But again, your risk then becomes greater. We talk about SOPs, etc., to manage risks during the installation process, during the maintenance, during the operational. All those aspects can be addressed, but now then we're relying on SOPs, for example. Whereas if we can achieve the desired result during the design phase, then it becomes a lot manageable. Okay, that's just an example of a risk assessment. So again, we talk about the life cycle of the equipment. What is our concern from a contaminant perspective? Very similar to the acid concept, chemical, microbiological, physical contaminants. What are we? Are we concerned about ingress, accumulation, and then also the likelihood, risk, and severity, as we know it in food safety terms. As we said, is if we can, during hygienic design phase, eliminate, we are proactive. If we do it later in the process, it is more a reactive approach to managing those risks. And then very importantly is that reporting, again, when we do a HACCP study, or when we do the same principles apply. So there need to be reports on how did we get to that decision, how was it made, and what was the thought process, and mitigation, etc. So guideline 58 has a number of tools that can assist us in conducting a hygienic design risk management, either of our equipment or our facility. Here's just an example. Here we have a low pump. So again, when we look at this low pump, one of the aspects of consideration is how do we clean that low pump? So how will we evaluate that? We'll have to do validations and see if it does clean in place, or is there a requirement for us to do manual cleaning? In other words, open the pump and then clean areas within the cavities of the pump. So again, we need to, and is it drainable? As I said, is that E8 would certify equipment as cleanable, but very important is that equipment needs to be installed in a proper manner. So we know in this position, for example, this pump will not be drainable. There'll be a problem with drainability, and that needs to be addressed. On the right-hand side here is just an example of a low pump that was tested and is E8 certified as cleanable. So again, there still need to be done a validation after installation, do a validation, do a verification, and but obviously this pump would be fully drainable and cleanable with CIP application. That's an example of a pump. When you look at hygienic design risk management from a facility perspective, what do we have in a facility? We have ceilings, we have doors, right? We have drains, etc. We have lifts, and here are the four aspects that we need to consider from a hygienic design perspective. So ability to clean, is it cleanable, right? Can it drain? Obviously, as I said earlier, you do not want, especially when you start looking at drains, drain location, etc., becomes very important. The slopes from the drains, accessibility to the drains, all those aspects need to be considered during the risk management process. This is just an example. So from a risk assessment, so we've done a risk assessment. Now we need to mitigate that risk. The aspect here is that microbiological spread that's linked to poor hygiene practices or equipment design limitations. Again, where this becomes important is if you have legacy equipment or legacy facilities, is to conduct the risk assessment specifically to that. Again, maybe not much thought went into the design of the equipment, and therefore we have to have various processes and procedures in place to mitigate that risk. So what are the root causes? There's non-drainable surfaces, right? And there's areas that's difficult to clean. You can just think of with inside a tank, we have a spray ball. If you don't have the correct flow, correct pressures to the spray ball, you're not going to get adequate cleaning result, and you might even have dead areas within the tank that needs obviously can't be reached, and therefore can't be cleaned. So that's the root cause. Improvement, slope drainable surfaces. That speaks to the hygienic design principle. The piping itself, here's an example of a dead leg that we see often in facilities as well, is piping either extensions or they would allow opportunity for further expansion, and there would be some areas where we find dead legs, and then improve cleanability. So from this risk assessment and mitigation, it's really a number of things that we need to consider, and only once that is done. So dead legs, do we remove the dead leg and fix it immediately, or how do we manage that risk? Again, we talk about efficacy and we talk about efficiency. Is we need to consider cost. A lot of work that we do in food plants is you can't flatten the food plant and then start from scratch. It obviously doesn't make sense, but it's identifying the risk and putting action in place, mitigating those risks, and then any new equipment or expansions to facility, etc., is to apply these principles, hygienic design principles, to manage risks. Here's another example of biofilm that build up in pipelines and in tanks specifically. The root cause is poor designs. In other words, you have crevices, you have rough surfaces that actually creates areas where soiling and microorganisms can actually stick to the surface and obviously cause problems within our product. So they would attach there. Yeah, we just have an example of, for example, welding. How many times in welding, and we've seen that you take endoscope and you do some endoscopic analysis, and you'll see what the inside of some of the pipes might look like. So we want smooth welds, CIPs optimized, and we want to eliminate any dead legs. So again, there's the risk, there's the root cause, and what do we do to improve the situation? That's just an example of open plant cleaning. And you can see the difference between that type of cleaning versus this. What is the risk? and how do we manage that? But same thing applies to our structure, our facility itself. There's just, again, drainage. What are they? What do we need to look at when it comes to drainage? Do we have areas where water and soiling can actually accumulate? Do we have access to drains to clean? Those are all aspects we need to consider. Uh, a number of times we see drains, especially when it comes to CIPs, where drains cannot actually cope with the amount of water coming through from the system. So there's a whole host of issues we need to consider. That's obviously a better design. There is a recipe for problems. So when we talk about optimization, I've mentioned one or two things about optimization. When you look at spray balls, it's just, again, the difference. What do you, from a choice of spray ball, you can see from a sustainability perspective, and you can see from an efficacy perspective, how that interacts in our decision making on spray balls. Here's an example of a study we did in South Africa, and this matter really related to CIP efficacy. So in other words, I don't get shelf life out of my product. What do I need to consider? And these are all the principles and criteria that we use during our evaluation process. From flows, there you can see welding, etc. But so we're not getting the clean result that we want. And then from this example was about efficiency. So in other words, it was about let's look at your operation, let's look at your design, let's look at your processes and see if there's any opportunity for optimization. And in this case, you can see the graphs indicate, and this is just from a chemical perspective, these graphs show you what was achieved during the assessment process and post validations and verifications. Again, all these aspects, the hygienic design principles, the installation of the CIP system, all of these aspects need to be taken into account and was taken into account to complete the study and achieve what we've achieved there. So again, using the guidelines, we as Centrotech of T Group, we are member of EH, and as such, we make extensively use of these guidelines in our operations and to support our customer base. So that is why I would like to conclude our discussion and our journey for today. I trust it has been interesting. It's concept that I think is long overdue in South Africa. As I said, we've seen more and more interaction between all stakeholders, and it's a very important topic, and we need to all become part of this whole journey in terms of addressing hygienic design as it relates to food safety. Thank you so much, Yandri, and thank you to all the participants again. Here's just a slide on my details if you would like to get into contact with us, or you can work through the DSA, and they will forward your mail to us should you have any questions. Thank you so much.
Oh, thank you, Piet. You could see the clapping of hands, so everyone will agree with me. This was really an insightful presentation. So thank you so much for adding value. And you will also see that if you want to recap on this information, we are going to, well, by next week, we will have it on our website. the recording of this webinar, so you will be able to recap on the information. But thank you so much, Piet. We really greatly appreciate you. Our next webinar will be on the 27th of May, and we'll keep you posted on social media, so make sure that you register. And that is all said. So thank you so much for your time. Have a wonderful afternoon and a wonderful upcoming long weekend. Goodbye.
Food safety. So thank you very much.
If anybody
Food safety. So thank you very much.
if anybody
Thank you very much.
if anybody